Let's talk a little bit about the periodic table of elements. The original periodic table by Dmitry Mendeleev, as seen here, was an organization of all 63 elements known at the time. As of today, there are currently 118 discovered or synthesized elements, as seen by this full periodic table. The first 94 elements, starting from number 1 hydrogen in the top left corner here, to number 94 plutonium, found in the actinide series, are naturally found on Earth, although some are in very, very small quantities. The other 24 elements, as shown by the strike through dark blue line, are only synthesized in labs or nuclear reactors. So what exactly is an element? An element is any substance made up of only one type of atom. An atom, if you recall, is the basic unit matter in chemistry, made up of protons, neutrons, and electrons. Let's take, for example, hydrogen gas, which is H2. Hydrogen gas is an element because it is made up of only hydrogen atoms. On the contrary, let's look at H2O, which is water. H2O is not an element, rather, water is a compound. And it is a compound because not only is it made up of oxygen atoms, it is also made up of hydrogen atoms. And as we know, an element can only be made up of one type of atom. So going back to the periodic table of elements, now that we know what an atom is and what an element is, you can see that the periodic table of elements could have been called the periodic table of atoms, because elements have to be made up of one type of atom. So let's look at how the periodic table represents individual atoms. It does it through element boxes. Here is a general template for element boxes in the periodic table I just showed you. In the top left is the atomic number. The atomic number is the number of protons or positive charges in an element. Since elements are neutral, the number of protons equals the number of electrons. So the atomic number signifies both the number of protons and electrons in an element. Second, we have the symbol. The symbol is a unique 1 to 3 letter code that scientists use to identify an element. The first letter of a symbol is always capitalized. Third, we have the name, which is the full chemical name of the element. And lastly, we have the atomic weight. The atomic weight is the average atomic mass of the different isotopes of an element, as found in nature. If you recall isotopes, an isotope is a type of atom that is missing or has extra neutrons. It is still the same element, it is simply called an isotope. So let's look at carbon-12, which has 6 protons, 6 neutrons, and 6 electrons. The 12 comes from the 6 plus 6 from the protons and the neutrons, as the mass of electrons is negligible. If we were to make this into an isotope by, let's say, adding a neutron, so now that it has 7 neutrons, it would now not be carbon-12, but rather it would be carbon-13, which would be an isotope of carbon. So going back to the periodic table of elements, let's look at hydrogen in specific with its element box. So here's hydrogen's element box. As you can see, it has all the elements that we just talked about. First, it has the atomic number. The atomic number of hydrogen is 1. Thus, hydrogen has 1 proton and 1 electron. Second is the symbol. Hydrogen's symbol is H, and it is capitalized as the first letter must always be capitalized. Third, the name of the chemical is hydrogen. And lastly, the atomic weight. The average atomic mass of all the different isotopes of hydrogen found in nature is 1.008 grams per mole. And this is denoted as simply 1.008 on the periodic table box. Let's now look at the relationships between the individual boxes and the way they're ordered. So there are two organizations. They're called groups and periods, depending on them being horizontal or vertical. The horizontal organization are called groups. As you can see, the groups are numbered here from 1 to 18. So in this periodic table, there are 18 groups. Groups normally share properties. So as we can see here, if we look at group number 17, as strike through here, group number 17 is normally called halogens. Halogen means salt forming, and all elements in the halogen group can react with hydrogen here to form salts. They share the same property in that sense. Another example is the noble gases, as denoted by group number 18. Noble gases tend to be inert and don't easily react with other elements. Moving on to periods. Our periodic table of elements has 7 periods. All of the elements in a period must have the same number of atomic orbitals. We can see this by drawing out hydrogen and helium from the first period and comparing them to lithium and neon from the second period. If you recall from the atomic number slide, the atomic number of elements is equal to the number of protons and electrons. So 1 electron for hydrogen and 2 for helium. And lithium's number is 3, so there will be 2 in the first atomic orbital and 1 in the outer atomic orbital. And neon is a noble gas, so it will be full with 10. So both atomic orbitals will be full. 2 on the inside and 8 on the outside. The periodic table of elements also groups together elements based on their metallic properties. Metals are elements that conduct heat and electricity really well and are also malleable and ductile, while nonmetals do not possess these qualities. Metalloids sit somewhere in the middle. Usually they exhibit non-metal properties, but in certain circumstances they can act like metals. On the periodic table, we see the nonmetals here denoted by yellow, sitting between the majority of the nonmetals and the metals. To distinguish this, we can draw a ladder down from boron all the way down to the right side of polonium and cancel out aluminum, which is a misnomer in this way of remembering. And now we see that all elements adjacent to this ladder of ours are metalloids. Silicon, germanium, all of them are metalloids. All elements to the left of this ladder now are metals, with the notable exception of hydrogen, and all the elements to the right of this ladder are nonmetals. This is a really cool way of remembering where if an element on the periodic table is a metal, nonmetal, or perhaps a metalloid.